Hello everyone, my name is Carissa Madonna. I work for the Department of Public Health Drinking Water section in the state of Connecticut for the past 25 years. I lead other staff in the Rural Implementation Unit for implementing the Safe Drinking Water Act and state regulations and statutes for all the drinking water rules. I am responsible for compliance activities of public water systems with respect to water quality monitoring oversight and compliance determinations, drinking water database inventory maintenance and updates, technical assistance, and more. I am the fluoride engineer for the state of Connecticut, and I am also a liaison with the Centers for Disease Control and DPH's Office of Oral Health. I have received my Bachelor's of Science in Environmental Engineering from Roger Williams University in Bristol, Rhode Island. During this presentation, we will discuss the Connecticut fluoridation statistics, water fluoridation benefits, the removal of naturally occurring fluoride, Connecticut General Statutes 19A-38, the monitoring requirements for fluoride, fluoride's secondary MCL and maximum contaminant level, operator safety, fluoride overfeed case scenarios, and lessons learned and response. A public water system means any water company supplying drinking water to 15 or more consumers or 25 or more people per year daily, at least 60 days out of the year. A total of 32 public water systems in Connecticut with 106 treatment plants add fluoride to their drinking water and report daily fluoride levels to the DPH drinking water section. Overall, an estimated 2.4 million people, or 86% in Connecticut, receive optimally fluoridated water from a water system. This percentage exceeds the level of fluoridation set forth by Healthy People 2020 to increase the proportion of the U.S. population served by community water systems with optimally fluoridated water. Some of the water fluoridation benefits include: when fluoride is applied in the right amounts, it promotes the development of strong and permanent teeth and is beneficial for both children and adults. Fluoride concentrations used for water fluoridation at the optimal level have no adverse health effects. Fluoridated communities have 20% to 40% fewer dental caries or dental decay. For those water systems that have fluoride above the maximum contaminant level of 4 milligrams per liter, there are treatment options to remove fluoride. This becomes necessary when you have fluoride above the MCL of 4, which can cause mottled tooth enamel or fluorosis. Dental fluorosis results from fluoride ingested during tooth development in children less than 8 years old. Some people who drink water that contains fluoride more than the 4 milligram per liter maximum contaminant level over many years can develop bone disease, including pain and tenderness of the bones. Excessively high fluoride levels, generally greater than 10 milligrams per liter, may result in skeletal fluorosis. Treatment options to remove excessive fluoride levels include reverse osmosis, ion exchange, and distillation. Water fluoridation legislation had been updated in 2016 for the Connecticut General Statutes 19A-38. This lowers the optimal fluoride level to the current U.S. Department of Health and Human Services recent recommendation for the optimal fluoride level, which is 0.7 milligrams per liter. The Connecticut General Statutes 19A-38 states that community water systems that serve over 20,000 people must adjust the fluoride level of the drinking water so as to maintain an average monthly fluoride content that is not more or less than 0.15 of a milligram per liter different than the United States Department of Health and Human Services' most recent recommendation for optimal fluoride levels in drinking water to prevent tooth decay. Currently, the optimal fluoridation level is 0.7 milligrams per liter. The regulations of Connecticut state agencies require public water systems to monitor their drinking water for fluoride. Community and non-transient non-community public water systems must perform routine monitoring for fluoride, which is required at the entry point of a water system, at least once every 3 years for groundwater sources, and annually for surface water sources. The regulations also require that the fluoridated water of each treated source is required to be tested daily at the entry point and maintained at 0.7 milligrams per liter as a monthly average. Additionally, public water systems that fail to monitor for fluoride during the required monitoring period will be required to issue a Tier 3 public notice that is within 365 days. Public water systems that have fluoride results that are above 2.0 milligrams per liter for the secondary fluoride maximum contaminant level requires public notification. The fluoride secondary maximum contaminant level purpose is to prevent the staining of teeth, mainly aesthetic and cosmetic concerns, which is not a health-based standard. The fluoride secondary MCL is 2 milligrams per liter. Additionally, fluoride levels above the secondary MCL of 2 will trigger a requirement for Tier 3 public notice that is within 365 days to minimize the potential for dental fluorosis. Public water systems that have fluoride results that are above the maximum contaminant level of 4 milligrams per liter require public notification. This is the maximum permissible level of a contaminant in water which is delivered to any user of a public water system. It must be economically and technologically feasible, and the fluoride MCL assures no short-term or long-term risk. Fluoride levels above the MCL of 4 milligrams per liter will trigger a Tier 2 public notification requirement that is within 30 days. To minimize the potential development of bone disease, including pain and tenderness of the bones. Certified water operators that work with water fluoridation treatment plants should use personal protective equipment when handling fluoride in the concentrated form, including a face shield, gloves, and aprons. The fluoridation room should also be well ventilated. Although fluoride is entirely safe at the recommended optimal dosage levels in potable water, like many things, it can be harmful when in the concentrated form. Fluoride chemicals used to add fluoride to the water include fluorosilicic acid, sodium fluorosilicate, and sodium fluoride. Operators must wear protective safety gear when handling or working with these chemicals. Ventilation is extremely important for these chemicals, especially the fluorosilicic acid, which can corrode everything in the room it is located in. Next, we will discuss 4 fluoride overfeed incidents that occurred in the state of Connecticut. We will learn about each case study, including the investigation, findings, and corrective actions that were implemented. Fluoride overfeed case study number 1. On March 6, 2008, an emergency fluoride overfeed was caused by certified operator error. A fluoride overfeed occurred at the well-filled entry point and was discovered several hours after the start of the overfeed. During an investigation, it was found that the certified operator did not dilute the concentrated fluoride chemical into the mixed solution. The public water system treatment plant was not provided with a continuous analyzer or high fluoride alarms. The incident was not found through the routine daily compliance sample taken earlier that day. The fluoride overfeed was later found during a daily on-site briefing in the afternoon. In this fluoride overfeed case, the corrective actions taken were The public water system was flushed and sampled until normal levels of fluoride were detected. The system later installed high fluoride level alarms and a continuous analyzer. Fluoride overfeed case study number 2. On September 13, 2007, a mechanical failure and a buildup of dry powdered fluoride chemical in the day tank had caused the fluoride overfeed. A public water system using sodium fluorosilicate failed to mix the fluoride solution properly prior to injecting the fluoride solution into the clear well. During an investigation, it was found that the inductor for the existing volumetric fluoride treatment plant didn't appear to be functioning properly. A buildup of excess amount of dry fluoride chemical and sediment was observed in the day tank. For this fluoride overfeed case study, the corrective actions taken were: the public water system had replaced the inductor and increased the flow of water into the day tank to attempt to improve the mixing of the sodium fluorosilicate. The water system was flushed and sampled until normal levels of fluoride were detected. The water system developed an SOP, or standard operating procedure, for overfeed response. The water system had later switched from the dry chemical volumetric feeder with sodium fluorosilicate to using saturators with sodium fluoride instead. Fluoride overfeed case study number 3. On May 14, 2014, an operator's lack of knowledge during the installation of a new pump had caused a fluoride overfeed. The water system operator had discovered a fluoride overfeed after the installation of a new pump at the treatment plant. During an investigation, it was found that the operator didn't follow the standard operating procedures, or SOP, for installing the new pump. The operator didn't calibrate the new pump properly. The operator didn't disconnect the fluoride chemical feed line during the installation. The operator had repeatedly cycled the new pump on and off, resulting in a buildup of high fluoride levels that was fed into the distribution system. For this fluoride overfeed case study, the corrective actions taken were: the fluoride chemical feed line was disconnected. The pump was calibrated and installed correctly. The system was flushed and sampled until normal levels of fluoride were detected. Follow-up samples for fluoride collected from the distribution system were all below 1 milligram per liter. Fluoride overfeed case study number 4. On May 16, 2015, a mechanical failure resulted in a fluoride overfeed. The water system failed to notify a representative of the drinking water section of the fluoride overfeed for 3 days. This fluoride overfeed had occurred after hours on a Friday. During an investigation, it was found that the fluoride high level alarm was triggered, which then notified the operator. The cause of the overfeed was a mechanical failure of the diaphragm of the back pressure valve, which then siphoned fluoride directly from the day tank into the distribution system. The fluoride level exceeded the maximum contaminant level of 4 milligrams per liter, which was at the entry point. For this fluoride overfeed case study, the corrective actions taken were: additional treatment operators were called in to assist and to begin backwashing the treatment plant filters. The distribution operators began flushing the hydrant outside the treatment plant. The operator replaced the back pressure valve and installed pressure gauges before and after it in order to have a visual check to verify that it is not still siphoning fluoride into the system. The operator diluted the water in the clear well with water that didn't have added fluoride to it. The water system was flushed and sampled until normal levels of fluoride was detected. For fluoride overfeed case study number 4, corrective actions continued. The water system believed the elevated fluoride levels didn't reach far into the system based on their initial sample results. The water system had left a message to notify DPH on the emergency after hours line on a Friday evening. The utility received a return call from the DPH duty officer, who does not work in the drinking water section, who failed to notify a state engineer at the DPH drinking water section of the emergency. The utility claims they were told to follow up with the drinking water section on Monday. So now we will look at fluoride overfeed lessons learned in response to fluoride overfeed incidents. For fluoride overfeeds, the lessons learned include decreased response time to an incident. You can do this by installing a continuous analyzer prior to the clear well to catch overfeeds early. Install high-level alarms and lower the set points of the fluoride high-level alarm. You can also think about lowering the set point below the 2.0 milligram per liter secondary MCL. Notify the DPH drinking water section as soon as possible during overfeed incidents and to receive further instructions from the drinking water section. Treatment system upgrades. Install an automatic shutoff for feed pumps and/or reprogram the SCADA system prior to detecting elevated fluoride levels at the entry point to prevent fluoride overfeeds. You can also change the feed pumps to pace proportional to flow. You will also want to reduce operator errors. Develop and review your chemical overfeed standard operating procedures, or SOP, and response plan prior to fluoride overfeed incidents. When calibrating a new pump, disconnect the fluoride chemical feed line to the water system. Run the water to waste instead. In response to fluoride overfeeds, you want to also reduce mechanical failures. Maintain and replace your equipment as needed. Public water systems may overlook something that is consistently reliable, such as a back pressure device, which had caused a significant and immediate impact to a water system in Connecticut. Install pressure gauges before and after back pressure valves to provide a visual check if there is water being siphoned. Reprogram the SCADA system to shut down the fluoride feed pump prior to detecting elevated fluoride levels at the entry point. Here are some of the steps your water system can do to take in response to overfeed incidents. First, you want to develop a chemical overfeed standard operating procedures, or SOPs, manual prior to a chemical overfeed event. Implement the standard operating procedure whenever an overfeed incident occurs. In an example, an SOP may include shut down the feed pump if feeding above the maximum contaminant level. Sample the area of the distribution system near the treatment plant. Flush the system in the area near the treatment plant with the fluoride overfeed. Investigate the cause of the overfeed and take corrective action. In response to fluoride overfeeds, you want to immediately contact the drinking water section as soon as possible for additional instructions. The drinking water staff are currently teleworking. Please contact our emergency phone number 860-692-2333 and report through the email at dwdcompliance@ct.gov email address. Request to speak to a drinking water section technical staff person directly. Do not just leave a message. Call and notify your local health department of the overfeed. And you will need to fill out the notification form, which is available at this link, and submit it to DPH drinking water section by the following business day after learning of an overfeed event. A fluoride overfeed is an event that requires reporting to the drinking water section and the local health department. This notification form complies with sections 1913B46 and 1913B102 of the Regulations of Connecticut State Agencies. This notification form must also be completed in response to a fluoride overfeed. Thank you for participating in this training. If you have any questions, please don't hesitate to contact me. Have a great day.